Welcome class to the first video. Right now you should have the green packet that you were given in class. You should be on pages 7 and 8. We are taking notes on section 1.1, which is identify points and planes. You can see at the top we have some objectives listed here. What we're going to do in this video, we are going to learn to name geometric figures, we are going to sketch geometric figures, and then we are going to determine if a point is on a given line. You will take the notes in this packet, and then when you come to class tomorrow, we will do some problems in class. So first we're going to write down the definitions for some important vocabulary. This is all the background for geometry. This is really important and we're going to be using it all year. You've probably learned this one before. A point is just a dot. Okay, so we have this figure on the right. We're going to write down some examples of points. One point is point X, another one is M, another one is G, etc. There's a whole bunch more. If you are writing a point, all you do is write the letter. That's it. So here I wrote X, M, G. There's no other notation. You don't need to put a point in front of it. You don't need to write point X. You just write a capital letter. If you write one capital letter, it's understood that you are talking about a point. Okay, a line extends in two directions without end. Okay, this one, the notation is a little bit more difficult. In order to denote a line, you need to pick 2 points on that line. So talking about this line right here, pick 2 points. Okay, I have point M, I have point N, so I can write M, N with a line over the top. I could have picked 2 other points. I could have chosen G and N with a little line over the top. You have to make sure you put a line over the top so it has the arrows at both sides. One other way to write a line, or to say that you're talking about a line, is with a lowercase letter. So we don't have one on this figure, but let's say I put a lowercase g here. I could also say line G, and it's one lowercase letter. Because remember, a capital letter is talking about a point. Okay, a plane is like a flat piece of paper with no end. Okay, so it's like you took a piece of paper, but then you continued it in all directions. Okay, for this one, you do have to write plane, and then you choose 3 points on that plane. So in this example, X is on the plane. I need to put 2 more points. B is on the plane, and A is on the plane. So add those 2 points to your plane, and then we would say plane X, B, A. Order doesn't matter. You can say ABX, BAX, BXA, as long as you choose 3 points. So I'm going to put that in parentheses. 3 points. So 2 points is for a line, 3 points is for a plane. Okay, next, a line segment is a portion of a line that has definite endpoints. It includes all the points in between those 2 points. So, for example, this right here is a line segment. It's just a part of the line. In order to write a line segment, you always have to use the 2 endpoints. So here the 2 endpoints are G and N, so I'm going to write GN with a segment over the top. We don't need the arrows because it's not a line. The arrows is only for the line. So in parentheses, we're going to write always use the 2 endpoints. Okay, so moving on. A ray is also a portion of a line with 1 endpoint and no end. So it has a starting point, but it goes infinitely in the other direction. So an example of a ray would be if we start at this point G, So that's the endpoint, and then it continued indefinitely the other way. So how to write this is we always write the endpoint first. So G is the endpoint. And then we write a point in the way that the ray continues. So the ray continues towards M. And then we write a ray over the top. The direction of the ray is really important. This is saying start at G, continue towards M. If we wrote it the other way, we wrote it like this. This is saying start at M and continue towards G. So this is saying start at M, continue towards G, which is different than what we just wrote. So those two are different. The direction that you put the ray is really important, and which point you put first is really important. So in parentheses, I'm going to put endpoint first. So always write the endpoint first. Okay, I know this is a lot of definitions. We still have a couple more. Collinear. Co means together. Linear means line. So collinear is points on the same line. So example, we see that M, G, and N are collinear. So M, G, and N are collinear. Remember that they're points, so we just write a capital letter. You don't need to put a point in front of it. You don't need to write point. Just M, G, N. Any 2 points are collinear. And we know that because it takes 2 points to write a line, or to create a line. Coplanar, if you could guess, are points on the same plane. Okay, a special note, any 3 points are coplanar. So in this case, X, M, and P, those are coplanar because they're 3 points. We don't see a plane through them in the figure, but there is some plane that exists through X, M, and P. Okay, we have 2 more definitions and then a few more examples. Okay, opposite rays are rays extending in opposite directions but they share the same endpoint. Okay, so I'm going to move this back so that we're looking at our figure again. So one example of opposite rays, we need 2 of them, is this ray right here, starting at G, continuing towards N, and then the opposite ray starting at G and continuing towards M. So GN and GM. Remember that the order is very important. G is the endpoint for both, so we would write GM with a ray over the top, and GN with a ray over the top. G is the endpoint, so G comes first. Last definition is intersection, which is the set of all points that 2 figures have in common. Set of all points that 2 figures have in common. Okay, so that was all the definitions that we're going to do. Now, if you would flip to page 8, we're going to do 3 examples together using these definitions. Okay, so here's example 1. It has this figure at the right. Example 1 says use the diagram provided to answer the following questions. Part A says give 2 other names for line PQ. We know this is a line because there's 2 little arrows over the top. So we're talking about line PQ, this line right here. So it's asking for 2 other names. One name would be QP with a line over the top. Remember, I just have to pick 2 points. You can also name a line using a little lowercase letter. So we can see right up here we have little n. So I could also say line n. We don't put a line over the top, we just write n. Okay, part B, give 2 other names for plane R. So this is the plane. The way I told you to name a plane is choosing 3 points on that plane. So one way would be plane VSP. So I chose 3 points. I could also say plane, using those 3 points still, just write them in a different order, PSV. So those are 2 names for the same plane. Name 3 points that are collinear. That's 3 points on the same line. We have this line right here. So I have S, I have P, and I have T. Those are 3 points that are collinear. And then 4 points that are coplanar, 4 points on the same plane, would be V, S, P, and T. Those are all the points that are on plane R, that red plane. So when we do some problems tomorrow in class, you're going to have a few problems that are like this. Example 2, this is definitely something that you've seen before. It says, is the point 3, 19 on the line y equals 4x plus 7? In order to determine whether or not the point is on the line, we're going to substitute this point into the equation. So I'm going to rewrite the equation, y equals 4x plus 7. Remember that a point is x comma y. Our y is 19, so I have 19 equals 4 multiplied by 3 plus 7. Now I'm not sure if these are equal yet, so I'm going to put a little question mark, since I'm trying to determine if they are equal. Okay, so is it true that 19 is equal to 12 add 7? Is this a true statement? Yes, it is. Okay, because it's a true statement, is the point on the line? We would say yes. The point is on the given line. So you always have to make sure you answer the question. If you just showed me this work, that wouldn't really be answering the question. Okay, moving to now we are at example 3. It says graph on a number line, and then tell whether the graph is a segment, ray, raise, point, or a line. So first thing is I need a number line. It says x is greater than or equal to 7, so my number line definitely has to have a 7. I'm going to go up to 8, 9. I'm going to go down to 6 and 5. Okay, x is greater than. That's going to be a closed circle at 7. Greater than is everything bigger than 7, so that's everything this way. So that's my graph. Okay, is this a segment? Well, a segment has 2 definite endpoints. This is not a segment, it only has 1 endpoint. A ray has 1 endpoint, and it continues in the other direction. So this would be a ray. Okay, so these are all the examples that we are going to do together. If you look, you have one more problem. It says, did we accomplish the objectives? We named geometric figures. Yep, we did that in example 1. We sketched. That was kind of example 3. And then we determined if a point is on a line. That was example 2. This last example, you are going to do on your own. When you come to class tomorrow, I'm going to check to see that you have this problem completed. Thank you.